This video is about a Dulcigurdy that I made some time ago, which people have asked about how it's made. The questions were in reply to a video called "A Dulcigurdy Needs No Gap Betwixt Strings and Fretboard." I have modified the Dulcigurdy a bit since then, but I'll try to explain how it works. The basic form of the instrument is that of a lyre, in that it has a rectangular frame and the strings are attached at this end. You can see they go through holes there, and they go under this bit here. There's a bridge here that pushes the strings downwards. Just move that out of the way. Yeah, bridge here pushes the strings downwards. The strings make contact with this raised part of the wheel. Then they go along here, go over a pickup. It's important that the position of the metal pole pieces on the pickup match up with the position of the strings. That determines what spacing the strings should be. Basically, the spacing of the pole pieces should determine the spacing of the strings where they go through there, where they're attached, all the way up to this end, where it determines the spacing of the strings here, and in theory where those machine heads are. Yeah, so the strings go from that way all the way along here to this cross piece, that would be called the yoke, and then to these machine heads on what would be called the head here, machine heads there. You can see more of why it's called a lyre if I remove the fretboard. Then it's much more like a lyre shape with the gap here and the frame there. The reason why it has a removable piece like this is that I was already making guitars that had removable pieces like that and had a lyre-like frame, and therefore tunings with frets in different places. This fretboard has 15 frets in an octave. The fretboard used in the video, "A Dulcigurdy Needs No Gap Betwixt Strings and Fretboard," is this fretboard, and it has 14 frets in an octave. This is a fretboard for conventional tuning, which has 12 frets in an octave. That one's 11 frets in an octave. You can put any of them on the Dulcigurdy or a different one, or have a fingerboard with no frets on it at all, and that's all fine. It all works with that system. There are various bits that it's important to be able to adjust. The wheel itself is kept flat by being pressed against this bit of wood here and that bit of wood there, by the force of the strings. But various bits need to be adjusted relative to that. The strings need to be pushed down against it by this bridge in a way that is adjustable for height and adjustable for position in this direction. So this here, that bit there, and a similar bit on the other side allow you to adjust the height of that by pushing it downwards. And it can also be moved this way to adjust the intonation so that the notes are in tune. It's important to note that on the underside of that bar, the actual bridge is this bit of wood here, and that's the bit that makes contact with the strings. It's in this case fixed on with a bit of blue tack. This bit here, where the fretboard meets the instrument here, that can be adjusted in height. At the moment, this is done by adding shims, little thin bits of wood or whatever, underneath here, And also here where this piece meets the frame, you can see there's more shims there. That's not a particularly easy way to adjust it. It's not easy to adjust it finely like that, but it does work. Here's an example of a simple system where you can adjust the height of where the fretboard meets the body there. This is a totally different kind of instrument, it's more like a guitar. You can adjust the height finely much more quickly and more easily than using shims with this system. But the important thing is, with this, you can loosen that here and then push this one way or the other and tighten it up again, and that will change the height of that. So the further this bit moves that way, the further the bit where the fretboard meets that bar moves this way. This is achieved simply by having a wedge and an angle to the bit of wood there. You can see how there's that angle there. So that the bolt goes through, there's also a slot cut in the wedge. Going further along, the angle here, the way the strings go over the wheel and then down, it's important to adjust that angle, and that's done by making it so that this piece here, the yoke, where the head is and where the fretboard ends, can be adjusted this way. And that's done by putting shims in here. So here's the frame of the instrument, there's the shim there, a thin bit of wood, and that pushes the yoke back, which adjusts the angle of this. That's important. On the video, a Dulcigurdy needs no gap betwixt strings and fretboard. The instrument didn't have this arrangement here. This is basically to push the strings down as though you were pressing them with a finger onto the 0 fret of that fretboard. The reason being, because when it was set up for that video, you only got notes if you pushed the strings down against the fretboard hard, and that meant that if you didn't have this bit here, the strings wouldn't be pressed down hard enough to get the notes when you tried to play the open strings. So this is to make it possible to do that. You could argue it's a bad idea in various ways, but in some ways it was helpful, so I went with it. This bit simply consists of a piece of wood with 2 holes in it, and then 2 set screws going all the way through there, through this piece of wood here to the other side, where there's 2 nuts locked against each other on each set screw, and then you have the compression spring here to push that bit of wood down, to push the strings against the 0 fret. You've got a washer there, that's about it really. You can pull it up and it's pushed back down. So that you can tune each string separately and easily, I've put in these little sort of ramp bits. If you can see that, hopefully. At the moment, all the strings engage with the wheel. So these ramps are to lift some of the strings up so they don't engage with the wheel, so only the particular string you want to tune at the time will be engaging with the wheel, and you'll only get that sound. So you can use an electronic tuner or something similar without having to worry about there being 2 or 3 notes going on at the same time. I'll just show you how this works. If I loosen this, we can push this that way, and then that raises the string so it's no longer in contact with the wheel, and you can push it further, and then you've only got one string in contact with the wheel because these two are both raised up. You can do the same thing with the other side so that you can select a different string. I can provide the formula for working out where the fret should be on the fingerboard. If you have a particular number you want me to calculate, then I could calculate it for you, but there are also online calculation systems where you just type in what you want and it gives you the information you need. This is just a cheap humbucking pickup that I got from Amazon. The signal from there goes to the jack socket, but also we have this earth connection that goes to the jack socket, and that's just twisted round one of the strings. It just has to be connected to one of the strings, and that's enough to earth it. It's not really that important anyway, I think. Depends on how much interference there is in the place you're playing. The pickup is just fixed onto this bit of plywood on the back. You can loosen this screw there and then move the pickup either way to try and line up the pole pieces with the strings. Then you tighten it again. It's just a slot that this screw fits through. The screws here go through there, and there's a spring on the screw, and then it goes into the threaded part of the pickup, so you can adjust the height of the pickup by adjusting that screw there and that screw there. The crank is attached here, and the crankshaft is just a simple piece of 6mm diameter threaded bar that goes through this piece of wood here, through that piece of wood there, which is attached here on that side, and similarly on the other side, and then it goes through the wheel, and then through the other side it goes through this bit here, which is the bit that transfers the turning force from the crankshaft to the wheel, and then it goes through another bar here to stabilize it, which is just attached here and there to the rectangular frame. This is the crank itself. It's just a knob from a piece of furniture. It would be a knob on a drawer or something, just with a bolt or set screw going through this bit of wood, through here, through the knob, and then a nut on the top, so that's all held in place. This bit here we have a T-nut, which is just a type of nut that you can get that presses into a larger hole, and it then means that you've got a thread that's nicely connected to the piece of wood. This is a piece of threaded bar of the right diameter and about the right length. This is an example of a T-nut. You can see the spikes it has, so that when you drill a hole of about 8mm in this case into the wood, then you push this in. The easiest way to get it to go in is to put a thread through and then tighten it, and it pulls into the wood, and then you've got this bit here that it's basically a bit of threaded stuff that is nicely attached to some wood. So this is the a shaft that could be a crankshaft. So if you imagine we've got this here, put that on there. Then this goes here, like so. Then this one can be tightened against the other until it grips the shaft very tightly. It's good to have this bit nice and long, that bit reasonably long, that bit reasonably long. That depends more on the sort of circle that you want to make. Then you can tighten one against the other easily using leverage, because that should be very tightly connected, otherwise it won't turn the wheel properly. Here you can see the instrument with the crank taken off. It's important that when the strings go through this bit of wood here and down, that they don't catch the wheel at the back there. They should just go straight from here to where the bridge is without making contact with anything else. Then they make contact with the wheel and go off along the fretboard. The strings on that Dulcigurdy at the moment are stainless steel wound guitar strings of gauges 26, 36 and 46. That's in thousandths of an inch. I'll work out what the metric is, but it may be better to use 3 strings designed for a cello, because then they're designed to be bowed, and the way the wheel gets the sound out of the strings is much more like bowing than plucking. So using a string that's intended to be bowed is probably better. The disadvantage is that I find it harder to get specific gauges of string when buying cello strings, but there may well be a way around that. You'd normally use 3 adjacent strings if you want it tuned roughly like mine anyway. So that would be like the C string, the G string and the D string, or the G string, the D string and the A string. Here's a selection of wheels for Dulcigurdys. This one resembles the one on the instrument at the moment the most in terms of its shape. The raised piece here, which you rub with rosin, is the bit that rubs against the strings and produces the sound. So that's the most important piece, and the rest is basically just to hold that bit in place and make it turn. The important thing is that the thickness should be constant all the way around, like this dimension should be constant all the way around the wheel. I've been doing that just by having plywood that I've bought and cutting out the shapes and screwing them together. You can see screws on the back where this bit of wood here is screwed onto the raised ring. This one doesn't have the extra edge around it that one has, that extra edge there. I don't think the extra edge is really necessary. When I was building the instrument, it was very experimental. I didn't really know what it needed. So I think this is probably better, but not important really. Both of these have one of those T-nuts in the centre, so they would be fixed directly onto the crankshaft, whereas the one, and that's how it was actually in the video, a Dulcigurdy needs no gap betwixt strings and fretboard, but since then I've decided that's a bad idea, and instead I have a system like this. This is a square wheel. It's easier to make than a round wheel, but the difference in diameter from the corners compared with the middle of the edges may be a problem. It might mean that you have less space to work in certain senses, but if it's not a problem, then by all means make a square wheel, because it's just easier. You just cut little strips and screw them again onto a square. But the important thing I want to show you on this is not that, is that it has two holes. That is the hole that the crankshaft goes through, but there's no T-nut there. The shaft just goes straight through and it isn't rigidly fixed there. The crankshaft goes through that hole and isn't rigidly fixed there, so this means that if the shaft becomes bent, then that should mean that the wheel can still spin on the level without being forced to move in the same way that the crankshaft moves. So if the shaft becomes bent, it should still run fine. Also, it means you shouldn't need to adjust the wheel to be on the plane when you set it up. It should just automatically be on the plane because it's held against the bits of wood behind it by the force of the strings. The crankshaft joins onto a bit of wood like this, which has a T-nut and also a set screw going through it. So this goes on here. Then this bit goes through here, and that set screw goes through a hole in the disc there, like that, so that when you turn the crankshaft, it turns this bit here, and that turns the wheel, so that this is fixed on rigidly to the shaft. As well as the T-nut on this bit of wood, we have a washer and then a conventional nut, which we then tighten up with a spanner. Then that's rigidly fixed, and when you turn this crank round, the wheel goes round as well, while this is being held in the level by being pushed on one side by the strings and on the other by bits of wood like that. The strings push down here, push down here onto the wheel, and on the other side the wheel is pushed against this bit of wood there and that bit of wood there. You can see this bit here, which is, see, that's the crankshaft coming out there, and this is the bit of wood that is connected onto the crankshaft, which then has the set screw that goes through the hole in the wheel. You can see how the set screw pokes through its hole in the wheel just there. When you've measured out the right positions on this piece of wood to be the fretboard, you cut the slots in the wood with a junior hacksaw. To see, sometimes I've got slots slightly deeper than the frets are. That's not a problem. You this is fret wire. You cut the fret wire to the right length using ordinary pliers. You can see there's the cutty bit there. Then put it into the slots, hammer it down, get it all even. There's a skill in getting the frets all even relative to each other. That's a bit of a longer story, but that's standard for guitars and other instruments with frets, so you can probably find that out somewhere else. The plywood to make these wheels is about 11mm thick, making them about 22mm thick in total. The radius of the outer edge of the raised ring is about 10 centimeters, 100mm, and the inner edge is about 80mm, 8 centimeters. Basically, the wider, the greater the radius of this wheel, the easier usually it is to get a good timbre. This fretboard is attached at this end by having a slot in the fretboard which goes around a set screw that goes through this bit of wood. You can see it on the back, that's a set screw. And at the other end has another set screw, bolt there, set screw, holds it down at this end and is tightened up by this wing nut. Whereas at the other end there's nothing to tighten up, it's just that the fretboard is held down by the force of the strings. If I loosen it, loosen that up, push that a bit, then you can pull this. That moves slightly further that way, then take it off like that. There we go. You can see this end, just a slot. The other end, you have the small slot that the set screw goes through, and that rests on this side on a ledge and holds it down by pressing on that ledge. You don't have to make it like that, it's just I do that because I happen to already have these fretboards, and then I can swap them over if I want to play music with notes, different numbers of notes in an octave or notes in different places, different tunings. I can swap it over and I like it. So I already have this technology though. I've made it for lots of other instruments like guitars and things, bass guitars, what have you. The holes through the wheel, that hole for the crankshaft and this hole for the set screw that drives it, should be very slightly larger than the crankshaft and the set screw are. So in this case the shaft is 6mm, the set screw is 6mm diameter in both cases, and the holes, this here, that hole is about 8mm, but it should be more like 7 or something, I reckon. And this here, that should be about 7mm diameter as well. I've made a slightly long hole rather than an ordinary circular hole because I wanted to make sure this was going to fit properly, and it doesn't need to be tight that way because it's not going to move that way. It just needs to be tighter this way so that it drives this, and when you change the direction the crank is turning in, there isn't too much waiting for the angle of the set screw to change before it engages with the wheel.